All right, so we are doing the 2020 independent paper question 21 worth 4 marks. You have a diagram that shows two identical cars, one on a rough flat surface and one on a curved horizontal road at uh, the angle of theta. Now it does say that there is a rough road surface, so friction is in this question. So you do need to consider friction when drawing this. Both roads curve towards the left, as you can see with the arrows, with curved parts of the same um, radius circle. With the help of additions to the diagram above, explain why the car can safely take the bank curve at a higher speed. So the first part you need to do is actually draw out the force components. In the first diagram we have here on the flat road, we have a normal force going upwards like that. And we also have a gravitational weight force pulling down. Now, kind of drew these diagrams a little bit different in length, but they are equal to each other. So that's one thing. Because the car is turning to the left here, so the friction force is also towards the left because that's the thing that maintains the circular motion. Okay, that allows the car to have that circular motion around like that. So that's why it needs to be towards the center point there. And that's how you draw the first one. The second one, we have a car. I'll just draw it here. We have the weight force down here. We have the normal force that's acting 90 degrees to the surface. So that's F normal. Okay. And then we have the centripetal force or the force component of Fn. So if I just draw Fn out like this, Fn, and then we'll draw another angle here, 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 here. So if it's a right angle triangle, so what I'm trying to gauge at is I'm drawing it like this. So just so you can picture with me, it kind of looks like that. The component we have as theta is over here, we have this side, so we have this component and this component here. So it's hypotenuse and the opposite side for this horizontal component of the normal force. So if I want to write that out, it is Fn horizontal, so I'll just call it H, is equal to normal force times sine theta. So that's one component that I need to consider here. So Fn sine theta there. The next thing I need to realize is this is on a rough road. So if it's a rough road, there is also friction here. Okay, so if I draw friction out again, so I'll draw it over here. This is friction, the value of friction. And we're using this triangle here. This is our weight force. This is theta. So the component I'm trying to look at the force component I'm trying to look at is this horizontal component that's derived from our friction force. Because friction is at an angle, it should have a horizontal and vertical components to it. Okay, so if I'm looking along here, so if I'm trying to write it out, friction is going to be cos theta of the horizontal friction component. So friction horizontal. Okay, so I'm going to call this, rewrite that, F friction cos theta equals to the horizontal component of that friction force. So not only do I have the normal component, I also have the friction component cos theta. Okay, so I have those two things. If I rewrite the centripetal force for both of these equations, it'll look something like this. So if we look at the flat road, the centripetal force is just friction. Okay. If I look at the banked road, that's going to be the centripetal force is the friction component or the normal component plus the friction component. What we can see here is the banked road has a higher, so we know that the banked road, so therefore the banked road actually has a larger friction force than the flat surface, or larger centripetal force than the flat road. Okay, because there are two force components or two centripetal force components. In comparison to 1. Therefore, as banked road has a larger centripetal force, according to our formula of centripetal force, Fmv squared r, therefore velocity is higher and safer on a banked curve or road. Another thing you can also add on to it is because it travels at a high velocity or there's a greater friction force, you have less deviation when turning. And hence why it's more safe. Now, thank you for listening. See you next time.